So this lesson is a review on converting between exponential and logarithmic forms, and we're also going to look at the two functions because we now know a lot about inverses. So just a quick review. So the exponential function f of x equals b to the x, where b is greater than 0, b is not equal to 0, is 1 to 1 on the interval from negative infinity to infinity. So it has a domain of negative infinity to infinity, and it either is going to be an increasing function or a decreasing function. So you can see it passes the vertical line test, so it's 1 to 1. So that means it has an inverse function. And the inverse of an exponential function with base b is the log function base b, written this way. And so we're going to go over how to find that. But let's just review what we can do with this fact here, and that is we can go from exponential form to log form and back and forth. So if you have exponential form, b to the y equals x, then you can write that as a log. If you remember, the log, the base b is a little subscript of x equals y, because a log is an exponent. So I kind of remember it this way actually. So for example, 3 squared equals 9 would be the log base 3 of 9 equals 2. 10 to the negative 3 equals 1 over 1,000 would be the log base 10 of 1 over 1,000 equals negative 3. So I think we've done these before, but you can pause the video and see if you can remember. I'm just going to do them. The log base 7 of 9 equals x would be 7 to the x equals 9. 3 to the 4th equals 81 would be the log base 3 of 81 equals 9. Log base 6 of 6 to the 7 equals 7 would be 6 to the 7 equals 6 to the 7. 2 to the negative 3 equals 1/8 would be the log base 2 of 1/8 is equal to the exponent negative 3. The log base 25 of 5 equals 1/2 would be 25 to the 1/2 power equals 5, which is the square root of 25 equals 5. We talked about the common log. If you see log of x and you don't see a number, a subscript, the base is 10. It's called the common log. We went over if you have a log base 10 and you have a power of 10, it's really easy to figure out what the log is. The log of 100 is 2, because 10 squared equals 100. The log of 1,000 is 3, because 10 to the 3rd equals 1,000. The log of 1/10, well, 1/10, you can use a negative exponent and pull that 10 from the denominator up to the numerator and use a negative exponent. When it moves from denominator up to numerator or vice versa, the exponent that was there becomes a negative. So the log of 10 to the negative 1 is negative 1, because 10 to the negative 1 is 1/10. We also talked about the natural log. The natural log of x is equal to the log base e, it's hard to see, that's base e of x. So the natural log of e is this nice property of 1. The natural log of e is 1 because e to the 1st power equals e. So I have a video for that. If I went too fast there, you can rewatch that video. What I wanted to focus on is something new, and that is the fact that these exponential functions and log functions are inverses, and I want to explore that so you can get a better understanding of that. So it says find the inverse of an exponential or log function. State the domain and range of the given function and its inverse. Also state the horizontal and vertical asymptotes, if any, and sketch their graphs. So basically, by the end of these two examples, you need to be very comfortable with exponential functions. Alright, so let's find the inverse of this function. Well, the steps are not going to change. So step 1 is rewrite that as y equals 4 to the x. Step 2 is to switch the x's and y's. Okay, so here, step 3, this is where the algebra happens, and you can't divide by 4, subtract 4. There's nothing you can do to get that 4 away from that y except this. You can rewrite it in log form. So we just learned it or reviewed it. B to the x equals y is the same thing as the log base b of y equals x. So that's what we're going to do with this. This is exponential form because it has an exponent. So I'm going to rewrite it in log form. Log, the base would be 4 of x equals y. And we did it. We got y by itself. So the inverse of this exponential function is this logarithmic function. Okay, so next let's talk about domain and range. Well, we said at the very beginning the domain of an exponential function is always going to be all real numbers. Okay, what's its range going to be? All right, well, let's look at the domain of this one. So we have a new fact here that you need to know. So I'm officially introducing it. There's a new domain restriction. So quick review, the two domain restrictions that we have learned and you have memorized is if you see a function and it has a denominator, whatever's in that denominator cannot equal 0. That's number 1. If you see a even indexed radical, whatever is under the radical has to be greater than or equal to 0. That's the second one. And now we have the third one, and this is the last one. If you have a log function, this spot right here has to be greater than 0. Okay, so here we have a log function. This spot has to be greater than 0. Now if we pull in what we've learned about inverses, we know that the domain and range switch. So now that I have the domain of both, I have the range of both. The range of this exponential is going to be the domain of the log function, 0 to infinity. And the range of this log function is going to be the domain of this exponential function. So now we have the domain and range. So we're learning about exponential and logarithmic functions. They are really good to learn at the same time. Okay, so now let's look at the graph, and we'll talk about the horizontal and vertical asymptotes. So I'm going to have to sketch this graph because this base 4 is going to get the output's going to get awfully big very quickly. But I did want to show you something that I'm introducing for the first time in my Math 171 class, and that is, I've never used this before, but I think it might be helpful. We usually ask you to use Desmos, but there is a table function right here. So if you hit this table, all right, and number 2 it says edit function, so you want to put the function in. So I've already put one in. Let's clear it. Okay, so if I want to put f of x equals 4 to the x, I'm just going to type in 4 and then this exponent button, and then this x, y, z, this is the variable button. It's got a bunch of choices. All right, if you hit it, it's going to give you x. All right, hit enter, and then it gives you a next screen, and it says table setup, and it says start. That means what inputs do you want to start with? So I'll start with a few negative inputs, like -2. And I don't want to count by ones. I think I'll miss too many interesting order pairs, so I'm going to step it by a half. All right, so I'll put 0.5 right there. And then you have a choice of auto, or you can choose the x values that you want to look at. I'm just going to keep it at auto, and then I'm going to calculate. And there it is. It gives you a table of values. So now what I can do is use that to graph. So when x is -2, y is, this is x, and this is f of x. Y is really small, 1/16. And when x is -1, y is -1/4. And when x is I'll skip the decimals. 0, y is 1. And when x is 1, y is 4. And when x is 2, y is 16, and we're off the page. Okay, if you want to look at smaller values, then you can keep going back, and you can see that when as x gets really negative, see how small y is. That e to the 11, I was going positive. Let me go back down. Let me go to the negative. Okay, so even though we started at -2, if we keep going up, it'll give you more values. So you can see that as x goes to the left, y gets really, really small. See that? It's heading towards 0. So this exponential function looks like this. It's going to hug this x-axis. That means that there's a horizontal asymptote, if you remember. Exponential functions have horizontal asymptotes of y equals 0. Alright, now remember, everything with inverses switches. So if this has a horizontal asymptote, then this is going to have a vertical asymptote of x equals 0. So I'm going to graph this log function. First thing I'll do is graph this vertical asymptote of x equals 0, and we're going to put values in so you can see those. So we'll go to table and edit function and put in this log button is right here. See that ln, log. Now you have to hit it 3 times. If you hit it once, it'll give you the ln function. If you hit it twice, it'll give you the log base 10 function, the common log. If you hit it 3 times, it'll allow you to change the base, and we want the log base 4 of x, and then I need to get rid of that. There, exponent. So I have log base 4 of x, and then I hit enter. We can start at -2 again, or can we? Can we put -2 in there? No, we have to start at something bigger than 0. So I'm going to put 0.5 in there and count by 0.5s. And then calculate, and it'll give me the table of values. And if I try to find values to the left of 0, it's going to give me an error. And it's even going to give me an error at 0 because 0 can't be in there. It has to be greater than 0. Alright, so we'll graph this. So we've got 1, 0. Let's see, 0.5 is -0.5. So 0.5, -0.5, and I could ask it for smaller numbers, but I know what's going to happen. All right, let's see. Going to have a lot of decimals, so we'll keep looking till we get a good one. 4. The log base 4 of 4 is 1. All right, and we're going to get a lot of decimals. There's a nice one. Log of a base 4 of 8 is 1.5. And we know that these are inverses, so they're going to be symmetrical about the line y equals x. So this is what a log function looks like. There's the line y equals x. So we've graphed a log function. It has a vertical asymptote of x equals 0. Okay, let's look at this next one. F of x equals log base 2 of x minus 3, and our job is to find the inverse of this. Okay, so we're going to write it as y equals log base 2 of x minus 3, and I added a little something there. There's a translation, right 3. So it's kind of going to look like this, but move to the right 3. Alright, now to find the inverse, we're going to switch the x's and y's. Okay, then we have, this is new algebra to you. How are we going to get y by itself? Well, we can't use multiplication, division, anything like that. We have to use our new trick of rewriting it in exponential form. This is log form. So we have log base b of x, or y equals log base b of x. To put it in exponential form, that would be b to the y, because a log is an exponent, equals x. So the base is 2, the exponent is x, and equals y minus 3. Alright, so then the last step, I can get y by itself by adding 3 to both sides. So we get y equals 2 to the x plus 3. So the inverse function is 2 to the x plus 3. Alright, next thing we want to do to explore is we want to write down the domain and range. You remember the trick to that is to find the domain first, because the domain has rules. So this domain, okay, we have a log function, and this whole thing right here, not just x, but this whole thing has to be greater than 0. So if I add 3, I find out that x has to be greater than 3. So the domain got shifted from 0 to infinity to 3 to infinity, which you should have suspected if you understand translations. Alright, the domain of this exponential function is always going to be all real numbers. There's no restriction on an exponent. You can put whatever you want into that exponent. So now I can figure out the range of this log function is all real numbers, and the range of this exponential function is going to be 3 to infinity. So if we graph it, this 2 to the x plus 3 starts, it has a range of 3 to infinity. So what that means, this in this translation here, this plus 3 moves this exponent, this horizontal asymptote was at y equals 0 for 4 to the x, but now this plus 3 is going to shift it up 3. So the horizontal asymptote is y equals 3. Okay, so let's graph it. So table, edit function, clear it, 2 to the x, then go to the right and make sure that you get off of that exponent spot. There we go. And now calculate it. There we go. And so we have negative 2 13/4. That's 3 1/4. And we have negative 1 7/2. That's 3 1/2. There's 4 right there. And we keep going. Let's see. 0 4. Let's see. 1 5. And we get the idea. So that's your exponential function. If your domain doesn't start till 3 to infinity, and we know what logs look like, and we know that inverses, everything switches. So if we have a horizontal asymptote of y equals 3, we're going to have a vertical asymptote of x equals 3. And this time I'm going to also remind you that the ordered pair switch. So if I've got an ordered pair of 0 4, then I'm going to have a 0.40. And I have an ordered pair for this exponential of 1 5, then I'm going to have an ordered pair of 5 1 for this log. And I know the behavior. I know it's going to hug that vertical asymptote and get bigger and bigger and bigger. And it does look symmetrical about the line y equals x. So this is just sort of a review of exponential form to log form, but also kind of putting together inverses are very useful for investigating log functions and exponential functions. And the way that you get an inverse of an exponential function is you rewrite it from exponential form to log form. And the way you go from a log equation to an exponential equation is you rewrite it from log form to exponential form.